we have here is the diagram shows a light, inextensible string passing over a smooth pulley. The string connects particle A to of mass 6 kilograms. So A is 6 kilos, so 6G going down right here. To pulley C, light movable pulley C. What does that mean about the pulley itself? Its weight is so low that they're just leaving it out. Okay. Over this pulley passes a second string. So a second string means you have two strings. Two different strings means two tensions. We'll go with T1 and T2 this time because I really don't know guess. Alright. Now, over the pulley passes X string which contains particle D of mass 4 kilograms. That's 4G right there. And then E3G. Find the common acceleration A of A and C. Find also the common acceleration F of D and E relative to C. Here's what's interesting here, right? Will we all agree that more than likely A is going to get pulled up and C, E and D get pulled down? You would think that, wouldn't you? 6G one side and an accumulation of 7G on the other, yeah? Now, if this was fixed and pulley C wasn't able to move, you'd be correct. 7G's outweighs 6G's, pulls up. But because technically, if you look at this system in isolation, if you just look at this part here and pretend it's on its own, if it's on its own, E goes up and D falls, doesn't it? Would you agree with that? And because they're moving and falling, it means you're not taking their full weight. Do you got that? You're actually not taking their full weight. And this full weight might be less than 6G and might be more than 6G. Bottom line is, we can't, in this particular question, it's a 50-50. But it doesn't matter. If you're consistent with your system, you're grand. So what we're going to go is on our initial intuition that A is going to go up, C is going to go down at acceleration A, E is going to go up, and D is going to go down. Because D is moving down on an object that's already moving down, what is D's acceleration in our opinion? A plus F. The acceleration of D, so you just write this down really quickly, just before you begin, just to make sure you got this. Acceleration of D is going to be F plus A. Acceleration of acceleration of E. Anybody? Sorry? Now, A minus F is under the assumption that overall it's going to fall. F minus A is under the assumption overall it's going to go up. An example would be A is 5 meters per second, F is 3 meters per second. A minus F is 2, so you're falling down at 2. However, F minus A is minus 2, so you're going the opposite direction. Okay, so just be aware of that. So A minus F is assuming that you think that the downward is bigger than the upward. Okay? And then what about then A and C are relatively similar, aren't they? Acceleration A is A and acceleration C is C. Everybody happy enough with that? Because A and C have no other moving parts, they're only connected by the one string. While D and E are moving parts that are connected to technically two string systems. Okay, now what we're going to do here is we're going to create tensions. You can be T1 and the second one can be T2. Now let's start off with equations. Let's start off with particle A. So lads, what's the formula for particle A? Can anybody tell me? Now remember, it's F equals ma, and we're assuming that A is on its way up. Any ideas? Okay, nearly. T1 minus 6G equals 6A. Everybody cool with that? Now, particle C, guys, or pulley C as it's called because it's a pulley. Pulley C is a weird one now, okay? Because, oh sorry, pulley C has a weight. Does it tell me the weight of C? Pulley C is weightless. Okay. So, pulley C is weightless. So, F equals ma. It's going to be 0 times A, which is 0. Because it says that C is weightless. Okay? But now we have to figure out what the F is. So, what is the F part? Now, let's look at things from pulley C's perspective on its own in isolation. Pulley C is here. I'm getting pulled up. It's getting pulled up by T1. However, it's also getting pulled down by what? Now remember, it doesn't take on the 4G and the 3G. It doesn't take on their full weight because they're moving. Okay? So, it's taken on T2 and another T2. Because the tension is what's pulling it down. So pulley C has been pulled down by 2 T2. That makes sense? So it's what goes, we're assuming that it's going down. Pulley C is going down. So we're going to write down the downward forces minus the upward force. So what's the downward force for pulley C? Anybody tell me? 2T2 minus T1 equals 0. So 2T2 minus T1 equals 0. T1 equals 2T2. Okay, so that is your second one done. Just give me a second. Temperamental there. There we go. So there's pulley C and pulley A, and particle A. So we have equation 1 and equation 2. Equation 1 followed by equation 2. Let's get on to particle D. Now, particle D, guys, F equals ma again. Are we assuming up or down for particle D? It can't possibly be going up under our system. There's two down. We're assuming one of the F is definitely downwards. A is debatably downwards. Okay, we don't know, but either way, we're directing them both down. So we're going to assume that F is going down. Therefore, its overall acceleration also going down. Yep. What is dragging D down? So you have your 4G going downwards, and what's going upwards? T2. Remember, it's called connected particles, so it's only what's immediately connected to it. Okay, so T1 is not connected directly to D, so therefore T1 cannot be in this equation. Only thing connected directly to D is T2 and your 4G. So we're assuming it's going down, so which one do we put first then? 4G comes first, minus our T2, and that's going to get us what? 4 brackets A plus F. Okay, particle D, done. Okay, so just put particle D down here. Call this equation 3. Now, we're on to equation 4, particle E. So guys, particle E, anybody? F equals F equals MA. Now, which way are we saying particle E is going? It's debatable, isn't it? Just be consistent. Choose one. You can't give me a wrong answer. Is it going up or down? Okay, let's say up. Okay, let's say it's going up. Okay? What force is going up to cause it to go up? T2. And what's opposing the T2? 3G. Its mass is 3. Now, you specified that it's going up. Therefore, I have to put the upward acceleration, take away the downward acceleration. So what's the upward acceleration? F. And then the other one? Minus A. You could do that the other way around by multiplying both sides by minus 1. Another person would come along and write it like this. 3G minus T2 equals 3 times A minus F. That's somebody who has the downward opinion, not the upward opinion. And as it turns out, they're both the same equation. It's just multiplying both sides by minus 1. Yep. Yeah. Is it? No. F is minus F. If it's going down, oh sorry, what I'm trying to say is overall it's going down. So A is going down, and opposing its downward acceleration is an acceleration up of F. Remember I said that particle E is a combination of A bringing it down and F bringing it up. The combination F minus A is assuming that F is bigger than A. So overall the acceleration is upwards. A minus F is sort of assuming that downwards is winning there. And that's why you have your weight leading your tension. Okay, either way, choose one, stick with it, get the same answer. Okay? Sorry, just nearly there. Okay, so that's equation 3. Now, multiply these out. T2 minus 3G equals 3F minus 3A. The next one, 4G minus T2 equals 4A plus 4F. Is that alright? Now, what we're going to have a look here, guys, is what is the question again? Find it wants you to find A and it wants you to find F on its own. A and F. Okay? So, A and F. Equation 1. Equation 2. Equation 3. Equation 4. So guys, my 4 equations are located here. What it doesn't want whatsoever is it doesn't want T1s and T2s, does it? It doesn't want them at all. So we're going to have to find a way to get rid of them. Okay? So what I'm going to do here is I'm going to get, let me see, T1 on its own. There's so many ways of doing this now, like there's so many different routes you can take to get this question out. Okay, and then T2 is 3F minus 3A plus 3G. Does everybody see that? And then let's link the two equations together using let's link the two equations together using, see the middle equation? Yeah, using the middle equation here, and then never mind that, scratch that. I'm going to get T2 on its own. T2 to the right, 4A and 4F to the left. T2 equals 4G minus 4A minus 4F. Now, okay, here's how I'm going to link them together. I'm going to use the two T2s. I'm going to put them equal to each other. I'm going to get out an equation with just a and f as the variables. Okay, that'll get me one simultaneous equation. So what I'm going to do here is I'm going to say 3f minus 3a plus 3g equals 4g minus 4a minus 4f. I've eliminated out the t's, which is great. I still have two variables. My two variables are the a and the f's. Move them all to one side. Minus 4a is a plus 4a. Move to minus 4f is a plus 4f. 7f plus 1a. Bring over to 3g equals 1g. That is one simultaneous equation right there. Now, the next thing I'm going to do after that is, see your T1 equals your 2T2? Your T1 equals your 2T2? I'm going to pick any of them I want. So T1 is 6a plus 6g. Circle this by the way, it's very important. Now that's T1 equals 2T2. Pick either of the T2s you want and multiply it by 2. So what I reckon I might do is I might just multiply this one by 2. 6f, 6a, 6g. 6f, 6a, minus 6g, was it? Or plus 6g? Okay. Look across now. The 6g's will cancel. And then I'm going to get 12a. 12a, I'm going to bring it over to your side. Minus 6f equals 0. There is my second simultaneous equation. Rearrange it to make it work, so it's going to be a plus 7f equals 1g. And now just got to make this work, okay? So multiply the bottom by minus 12. Multiply with minus 12. And we're going to get 12a minus 6f equals 0. I'm going to get minus 12a. What's minus 84f, is it? Minus 84f equals minus 12g. Minus 90f equals minus 12g. F is going to be, what's 12 over 90? Can you tell me?
2 over 15.
Sorry? Is it 2 over 15? That would be brilliant if it was. 2 over 15g for F. Then find out what A is. Well, we sort of found out a pretty good relationship here that like 12a equals 6f. Therefore 2a equals f. A equals f over 2. Therefore A equals 1 over 15g. Okay?